Hello, students, and welcome to today's lecture on sealants and packing. In engineering applications, especially in compressors and machinery, preventing leakage of fluids through surfaces, joints, and openings is critical. This is where sealants and packing play a major role. Today, we will explore their types, design considerations, importance, functions, and best practices. Let's begin with the first topic. Sealants are substances used to prevent leakage of fluids through surfaces, joints, or openings in materials. They are used for fluids under both high and low pressure, and at varying temperatures, whether corrosive or non-corrosive. Sealants are not adhesives, but some may have adhesive properties and are called adhesive sealants. They can be weak or strong, flexible or rigid, permanent or temporary. When compared to adhesives, sealants have lower strength but much higher elongation, meaning they stretch more. When used between materials that expand differently under stress or temperature, sealants need flexibility and good adhesion. They are commonly used to close small openings that cannot be sealed using other materials. Their important properties include insolubility, corrosion resistance, and good adhesion. Packing is essential for sealing moving parts such as piston rods and compressors. There are different types: metallic, floating, segmental, or mechanical. Metallic packing were used in early machinery when most parts were made of metal. Floating packing are the sealing rings that move freely with lateral movement of the piston rod. Segmental packing are rings that are made in segments for precise sealing. Mechanical packing are precision machine component that functions on mechanical principles. Packing designers must carefully consider several variables, like type of gas, suction and discharge pressures, temperature, speed, and stroke length, lubrication, rod material, dimensional limitations. These factors are crucial for efficient and safe operation of compressors and machinery. Packing is one of the most critical components in compressors and related machinery. Failure of packing can result in plant downtime, loss of production, high maintenance costs. So, the reliability of packing directly affects productivity and safety. The main functions of a caulking sealant are: it can fill gaps between two or more substrates. It forms a barrier using both physical properties and adhesion. It helps in maintaining sealing performance throughout its service life. Sealants may be viscous, so they stay in place, or thin and runny, so they penetrate surfaces by capillary action. They must be properly formulated for specific applications and performance needs. Anaerobic acrylic sealants cure in the absence of air, unlike surface sealants. They are designed to prevent penetration of air, gas, noise, dust, fire, smoke, or liquids. Their curing mechanism and sealing performance make them highly desirable in many engineering applications. Sealants range from high-strength adhesive-derived sealers. 2. Low-strength putties, waxes, and caulks. Putties and caulks only fill voids and take up space. Silicone is one of the most common sealants used in industry. Let us now look at major marine sealants used in ships and boats. We will start with silicones, which is very easy to apply and elastic, excellent for isolating dissimilar metals, resistant to chemicals, works like a gasket, not a strong adhesive. Cannot be painted, nothing adheres well to it, compatible with plastics but weaker than others. Next is polysulfides, which is made from synthetic rubber, available in 1-part and 2-part systems. 2-part often used for teak decks and wood bedding, bonds well to most surfaces. But not plastics or windshields. 1-part version cures slowly but is very durable. We also have polyurethanes, which is more of an adhesive than a sealant, ideal for permanent bonding, such as hull deck joints, poor resistance to oils and acids. But it is not suitable when future removal is required. Sealants are available in various containers and hand-operated systems. They are designed to create water airtight seals, join surfaces, often with fasteners, isolate surfaces to prevent noise or electricity transmission. Silicone insulates metals and beds plastics. Polyurethane should be used only when separation is not required. Polysulfide is the general-purpose marine sealant. New advancements have made epoxy sealants more flexible and less brittle. They cure faster than some polyurethanes and adhere well to fiberglass, wood, steel, and aluminum. They can be removed later without cracking, making them increasingly popular. To ensure proper sealing, we should keep certain points in mind. We must follow product safety and application instructions strictly. Surface must be clean, dry, and free from old sealant. Clean with acetone or other recommended cleaners. Use liberal amounts for deck hardware if specified. Curing time may vary from 5 to 20 days as stronger sealants take longer. Moisture speeds up curing of polysulfide and polyurethane. Use mineral spirits, acetone, or kerosene for removal. Always follow manufacturer guidelines for cleanup. Sealants and packing are essential components in mechanical and marine engineering. Their selection, formulation, application, and maintenance decide the efficiency, durability, and safety of a system. Thank you for listening.